All right, so this is our final project about food access. More specifically, we'll get into this later, different levels of food insecurity in different counties in California. So first off, we imported this food access database from Corgus, and it's in this pickled format, so we had to run this function to get it to be working for the rest of our files.
Mhm. And then for our county class, we called it county demographics. Each of its attributes are county, string, population, integer, and then a dictionary for each of their of given subpopulation and their distance, and then their state. And then here's the REPR in its standard format.
Yeah, just to touch a tiny bit more on the different dictionaries within the county demographics objects. It's basically saying like at this level of distance from a supermarket, there's this population of children or low-income individuals, etc.
Yeah. And this is just an example of what our original data looked like, just a nested uh, amount of dictionaries. So it would be a county, and then you would get the value, which is string, and then of course is dictionaries within a dictionary. And to convert that to a more digestible format, which is our class, um, we created a function, and within this function, we just create a new list, and for each county in the raw data, just get their just get the values that we wanted and output it into a county demographic list. And then for the second function, it was just to basically get once again a list of county demographics for a given state. Within our case, it was California. And then here are their variables. So list of counties is the variable that we use, and then California. And then here's the functions.
Yeah, so to run through the first two functions real quick. Basically, what they're doing, obviously, we imported all the data and relevant, object, the class definition up at the top. So the first function here. Basically, you enter a county and a level of distance from a supermarket, since that's what's in our data. And then it returns the number of children that live at that distance from a supermarket in that county, divided by the total population that lives at that distance from a supermarket in that county, and then multiplies that by 100. So it's basically saying for the total population in that county that lives at that level of distance from a supermarket, what percent are children? And then function two is doing something very similar. It's just the percentage of that population that has low income.
Mhm. For my function, it was of course the same process just for seniors. So you get a county, a level, 1 mile, half a mile from a market, and you would get the percentage of seniors from that within that distance. And if it for some reason an error occurs, it would output error message in the display. And then same thing right here, just for the total population. So we'll divide the total subpopulation of low income, and then divide the by the total population of the actual county. And then of course an exception as you print out if any error occurs. And here's the function test.
Yeah, so we just tested these functions on basically a condensed version of our total data list. So instead of, however many lists or however many county demographics objects were in the entire data set, we just tested our functions on the reduced data list, which is just a couple counties.
Mhm. And here's the test. I could show that right now. So all 8 of our tests pass of just like input, reduce data, result. Uh, of course, just put in our input, 10 miles. Our expected output was just from manually doing it ourselves from this reduced data and then self dot assert. And that's basically what we did for each one. And then round to two. And then here's our last one, input display.
Yeah, so for these, we wanted to give a way for this code to be a little more interactive. So basically, what these functions do is you enter a given level of distance, for example, 1 mile or half a mile, and it returns every county in California, and then uh, it returns a list where there's sublists for each county in California and the result of each function for that county. So if we want to run them and just enter, 1 mile for each of them, it'll show the results for all the different functions for each county in California. And there's a little bit of text in the output there. You see the following is a list of all counties in California paired with the percentage of their population at the input level of distance from a supermarket that are children or low income or seniors, just to explain it to the user. And then there's all those county names and percentages. Yeah, and then just to touch on the social responsibility aspect of this a little bit, this really provides the code in this project really just provides insight into different counties in California, how they're dealing with food insecurity, how they're doing with regard to food insecurity, could be used to, maybe set policy like, hey, we need to direct more resources on the part of the government to, increase food access in specific counties based on data output from this project.
Yeah.
All right, thank you.
Mhm. Thank you.